Welcome everyone. This is the continuation of the previous video on binary search, and I have already explained about the algorithm, the steps that we use in binary search. Now let's start the program. Now in the program, first of all, we will initialize a list. You can also do so by just asking from the user. Okay, I've just made in this way so that you can it's shortened. Okay, the program code is shortened, and you can also modify this by asking the input from the user and append it to list as they enter the numbers. And of course they should enter in order. If you still remember that binary search, always to enter in serial order, whether ascending or descending. So in this case we are creating a list in ascending order, after which the next thing that we do is we ask for the item to be searched, which means which item they want to search, and you put in one variable. You can name that variable anything. Here I've named it as item. Then after which you will call the function. Okay, that is for binary search, right? So in our case, our function name is bin search. So we call it in this way. We have assigned it to res. Okay, so the function call starts from here, bin search, and we are sending the list and the item. The list means the entire list that we have created, and item mean the one that you've asked from the user. So that's a list and the number to be searched. Now your function starts, and then this function takes two arguments, and that is the list that you have sent and the item. So the item will be stored in key. So the first thing that we do is we initialize the first index to low, and also the last index to high. So you can have a different variable name as well. Now as for high, we are not going to give any static number. We are going to say length AR. That means it will get the entire size of the list. In this way it is flexible. A user can have, we can have any size of list. So len will give you that size, and then you just minus 1 from there, meaning if the size of the list is 10, you're minusing 1, which will become 9. If it is 100, it's going to be 99, because the index always starts from 0. Okay, so it will never be 1 to 10, it will be 0 to 9, and it will never be 1 to 100, it's going to be 0 to 99. After which, when you're done this, you start the loop, and the loop should go as long as the low is less than equal to high. That should not go way beyond the size limit or the index that you have set for high. That's the size minus 1. Then you get the mid. And how do we get the mid? By adding low plus high, that's the first index and the last, and you divide it by 2. And since we want the answer to be an integer, so we cast it into in and we store it in mid. Then we start the condition. First of all, we will check if that item is equal to that number which we have extracted from the middle, okay, as AR mid. And if it matches, then simply we just return mid. But in case it does not match, okay, so what we do is we check for another condition, and that is we check if that item is less than that number that you have extracted from the middle. All right, and if it is less, then you're changing the high will become mid minus 1. But if this also is not true, which means the item is not less, then we have another function, that is another condition, okay, where we have kept in a else part without any condition here. So the else part will be low is equal to mid plus 1, which means if it is less than, we will change the high, and that high will be from that mid, you're going to minus 1. And if it is low, you are going to change the low, which was 0 previously, you're making it mid plus 1, which means going ahead from that middle section, okay, by 1. So it's simply in this way. If suppose the middle is 428, if the number is less, then we make this high mid minus 1, which means 3 will become your high. But if it is not less, which means it is this side. So in the else part, we say low. The low which was previously 0, we are making it mid plus 1, which will be 5, which means low will start from 5, right? Then that's the end of the loop. And also we'll check if suppose all the three condition does not match. Let's say if the number is not here, it's not going to be equal to, it's not going to be less than, it's not going to be greater than. So then we have the else, then this loop after it finishes all the loop, it comes out and it's not going to return anything. So we keep an else part where we will return minus 1 if there the number does not match, okay, and we don't happen to return mid, right? So after we finish this, so the function either it will return mid, that okay, return mid, or it will return minus 1. If the number is there, it's going to return mid. If the number is not there, it's going to return minus 1. Then rest will store the return value returned by a function mid or minus 1 because of the assignment while calling the function in the main program. Now, as we go to the main, remember whatever the function returns is going to come in this line and get assigned to rest. So rest will have either mid or it will have minus 1. So when you come back to the main, that's why we need to give this condition. If res is greater than equal to 0, that means mid has returned something and the index return will be always be greater than equal to 0 because the index always starts from 0, right? So anything above zeros or equal to 0 would be that in between the range of the index, which means mid has returned. So you just have to print that item found at that index. And if you want to print the position, you can make it plus 1, else you make it just rest. Rest will just give you the exact index number, but plus 1 will give you the position as well. Else it will print sorry item not found in array. Okay, so if as for the position, okay, why do we give plus 1? Okay, if you still remember, okay, that if we want to give the position, is always not from 0 in this way, is from 1. So if you are returning 4, your position will be 5. So the index starts from 0 and your position will start from 1. Remember that. So if mid returns 8, the position will be 9. So if you want to straight away, print 8, then you can just put rest. But if you want to print 9, you just add 1 to that 8 that's returned. Hence, you're going to get the position, okay, this way, which is rest plus 1, okay. So the position will always be the index plus 1. But if you want to print just the index, you give just the index, which will be stored in rest. So you don't have to give plus 1. Right? So if you want to give in this way, which means you're printing the position. So you will say found at position rest plus 1. Otherwise, you can say found at index rest. Right? So with this, I hope you have understood. Okay. And we'll just go to the program that we have created. Okay. And just to see the overview of what we have written. The low is equal to 0, high is equal to length AR minus 1, while low is less than equal to high. Then we get the mid and then we check if it's equal to. If it's equal, we return. Otherwise, we check if it's less. If it's less, we change the high, else we change the low. And high will be minus 1, low will be plus 1 of the mid. Otherwise, if you see, the else portion is a part of this while. So this else is a part of the while, which means if this while loop finishes, then it comes to the else part. Okay, but it will never come here if suppose in any of the iteration, okay, it returns mid, it will come straight out from there. It will never come down here. Okay, but if the number is not there, so it's not going to return mid, so it's going to come to the return minus 1. So the same program you can also do in recursion, okay, recursive way, and with that just a little changes same way. instead of using, remember, recursive function is like a loop. Here we're using while. Okay, so that's why it's keep the iteration works and from one step to the other to check the number. But in recursive, we are not going to use loop. We are going to use recursion, that is by calling the function again and again. So we just check first if it is low is greater than high, which means it's just like we're ending the loop in this way. Okay, so we are not using the loop, so we do in this way. If low is greater than high, straight away you return 1. Otherwise you get the mid. Then again you check if the key is equal to, the item is equal to AR mid. Otherwise, if it is equal, you return mid. Otherwise, again, if it is less, you will change the high, right? And then again, you after changing that, you need to call the function, that is recursion, and check the difference. Here we are going to not send just the list and the item, we also sending the value of low and high. We just change because you have changed high, so high will have a different value. Of course low will remain the same because in this particular condition you are not changing the low, so low will remain the same. But in this one, suppose it comes with this else part, okay, where you're changing the low, then of course low will have a different value. So that's why in each condition where you're changing the high and the low, you need to change that new value. So this argument, then you will be thinking, then why not send just the low, why not send just the high? If you still remember, in function this parameter should change with the argument, should match with the argument that you're sending. If you have 4 arguments or parameters, the argument should be 4. So that's why we send all of them again, though it has the same value. Another changes that you have to make is when you call the function. Previously you were giving just res bin search and you're sending just the list and the item, but since now you have these parameters, so you are going to send the entire parameters, that is all the 4. Okay, so if you want to run this in recursive way, you have to change your function call in this way. Okay, so I have commented that previous one. So if I run this, it's going to be the same. Okay, enter search item. Okay, let me just start from the beginning. Okay, enter search item. If I say, let's say 34, I don't know whether 34 is there. No, it's not there. Okay, we have some indentation problem here, as you can see. Okay, fine. Okay, let's just write 28. So it's saying that there's a problem here, and I think that the name of the function should be bin search 2. Let's check the name. Yes, it is bin search 2. So we are calling bin search 2 now, not bin search 1. Okay, this is the recursive way. And let's enter 28 and just a minute. Okay, 28. So it's found at index 4. So let's check if 28 is in 4. Yes, 0, 1, 2, 3, 4. And as I've said, if you want to change, you, you don't want to print the index, you want to print the position. The position would be 1, 2, 3, 4, 5, not 4, right? So you just have to add plus 1 here. As I've said, if you want that it should print position, not the index. Let's save this and run again. Let's give the same 28, and you see that 28 found at position 5. So depending on if you want to print both, you can do so. In the same line, you just add here another one, like item found at index res. Okay, the same if under this block you can add another one. Otherwise a spare. If you want just the res, just the index, you give just res. If you want position, you give res plus 1. So thank you.